Johnny unmute. Hi guys, I hope you can hear me. Let me share my screen. We're going to randomize whoever is leading this session. It's only the two of us. It's me and Kevin. So if you can look at my screen, Kevin, pick two numbers between between 0 and 3. Yeah, 0, 1. Between 0 and 4. 1 and 4. Getty will get 0 and 2. Okay, so we have two sessions. The winner will be leading the first, the loser will be leading the second. But if Kevin wins, he can lead the whole session. Round 4. First is 3. How come we don't have 3? Anyway, 3 again. 3. 1. Kevin will be leading us. Thank you.
Okay, so welcome to today's mob. Today we'll be looking at class module design and naming. Okay, so the fact that Ruby has classes and modules, along with the fact that from an object's perspective, all that matters is whether a given method exists, not what class or module the method definition is in. So means you have a lot of choice when it comes to your program. So if you have a method, we usually only check if we have defined that method or if it's defined somewhere. We are not concerned with the class that it really belongs to. Yeah, or maybe the module where it is. So previously there was the stack like where it will have been possible to put all necessary method definitions in one class, but it was advantageous to yank them. So that was previously when there was that stack and stack like where we were using inheritance. Yeah. So there's no rule for deciding whether to do either the inheritance or use modules. There's really no rule. It depends with the present and to the extent you can predict them. So it depends with maybe if you had a plan, maybe if you, for example, you can use a module because probably in your plan, in your project, probably you're seeing that your module may contain maybe some other collection, or you're seeing that with time, probably if you had classes, in your classes, you'll be including multiple modules. So, and you'll not be doing multiple inheritance. So in such a case, you'll go for modules such that later on in your classes, you can just include the modules. Okay, so it's sometimes tempting to break everything into your separate modules because you write modules for one program. Yeah, because modules you write for one program may be useful in another. Yeah, just like I'm saying, if you define one module, you can include them in multiple classes. So I just know I'm going to need that again someday. Yeah. So, but there's such a thing as over modular. Okay. So that's just like having too many modules. So it depends on the situation. You've got a couple of powerful tools available to do the mixings and inheritance. So maybe you may have too many modules, but probably in a way you could have structured your code better if you mixed inheritance with modules than only using modules alone. I think that's what now over modularization is using. Yeah, it's like you have too many modules when probably you could have used both inheritance and module in your. Yeah, so this part. Oh, so we have the mixings and inheritance. So usually mixing modules is just this, is not the same, is closely related to class inheritance, because in both cases we have one. In both cases we have one entity establishing a close connection with the other by becoming neighbors on the method lookup path. So this means if you have inheritance, if you have used inheritance, so if you defined a method in your class that has a superclass, the method lookup will switch from the, if it is not in the subclass, it will check in the superclass. That's the connection that is there at that point. And if you use a module, if it's not part of the class, it will check in the module. Yeah, it's like the way you just have a neighbor. If you want something that you don't have, probably you can go and ask your neighbor for some help. Yeah. Okay, so our cargo hold is an example. We implemented it by having mixing the stack like module. So yeah, that was way up. Let me see if I can backtrack to that. Oh man, what? Hey, it's really far. Okay, let me just continue with this. So yeah, there was a time we created a stack like module, where we had a stack class. Yeah. So in this case here we have a stack class. This is the stack class up to there. It has an attribute to read a stack, an initialize method. So every time you create a stack instance, we create or we initialize an empty stack array. Then it has a method of adding to stack. So adding to stack, whatever you pass there, it will add it to the stack, which is this empty array. Then it also has the take from stack, which you now use pop. Pop removes the last element, first in, first out. Yeah, LIFO. Okay. Then we have a suitcase class. Then now we have a cargo hold, which in this case now inherits from a stack. Makes more sense. Then in the cargo hold, now we have a load and report. This is just printing that loading object. Then it's just showing us the object ID just to see which object we are here. Then unload is the same as calling from stack method, which is, where's the from? Oh, take from stack, which is here. Yeah, so from this point of view, if we have now a cargo hold object, so for example, initially we had here we are inheriting from stack, but initially we had a stack like module which we were including in the class, then using the methods in the modules. But in this case now we are doing an inheritance. So here the object is concerned with finding and executing that correspond to the messages it receives. So when you create an object here, and call maybe, let me say, if I call take from stack, okay, I think the best way will be, let me copy this. Oh boy.
It's hard to use a mouse for the first time.
So let me go to try. Then I have my stack class there. Then I have yeah. Linux. So in this case, you have a stack. So let's initialize. Okay, let me call it A. Let's initialize a new stack. So notice in this case, if we create an instance, it has so every time you create a stack, it initializes an empty array. So now that we have a stack, we can add the stack. Yeah, let's add some numbers. That is the first. So we have to, let's add, then let's add, so this time our array has 2, 7, and 5, yeah? How about, we have created I was to create actually an instance of the cargo hold class. But it's okay. We have seen how the add to stack method is working. Let's create a cargo hold class. So notice here that the cargo hold, in instantiating the cargo hold class also initializes or an empty stack or an empty array. But notice in the method, we don't have an initialize method here. So what actually happened at this point is usually, if we call a new, it usually looks for, new actually usually looks for an initialize method. So it will come to the instance, it will come to the class cargo hold. It won't find it. It won't find it, but it will see that, it won't find it here, but we'll see that we are inheriting from stack. If you're inheriting from stack, then it will go there and find we have an initialize method. So it will execute this instead. That's why you notice you have this. Yes, get a question?
I had a question.
Yes.
So, they usually Tanzania me. So, when you talk about an attribute reader and an attribute writer, can you show me the difference between this here in this?
Okay, so the difference between an attribute reader. So, how can I? So actually, an attribute reader is usually, so for example, here we have an attribute reader stack. So it's like you have an attribute reader stack. How will I explain this? If I call stack dot stack. Oh, that's not. How can I? Which one is a good example?
We'll do it in the next session.
Okay, but we have an attribute. We usually have attribute accessor, which is a combination of an attribute reader and an attribute writer. Then we have, if you have used a getter and a setter, a getter is the attribute reader. A writer is the attribute accessor. Attribute writer, if you usually define it, it's usually the method. For example, it will be something like stack equal. The value there, that's an attribute writer. Then attribute reader from the method is just like you are getting a value. Yeah, you are getting a value that you have set. Yeah. So, we created an instance of the cargo hold. Then we saw that an empty array is initialized. So at this point, if we now have s dot, assume we want to add to stack, yeah? We want to add to stack. Yeah, notice the add to stack is not really in the cargo hold class. But actually where it got it from is its neighbor. It was missing here, then cargo hold has a neighbor where it can look for help. So it went to the neighbor and the neighbor was of good service. Yeah. So if we have, okay, let me call another method. Let me just add another element. Add another one. That's the last one. So now I have 4 elements there. Let me again call which method? Let me take from stack now. Take from stack. I want to take, let me take, take from stack doesn't really take an argument because it does the popping, yeah? So, and it returns what it does. Its return value is, yeah. So in this case, let's see what's S. If we look at S this time, we have only 32, 4, and 5. Yeah. So which one else? Let's load and report. Let's see the result of calling load and report. A wrong number of arguments. Load and report takes the object. So load and report. So loading object 7. Loading object, then object ID is 7. Print has, after printing, doesn't go to the next line. So that's why it has printed loading object, then immediately 7. Yeah, then adding to stack, which is now, adding to stack, we see returns our new array, like we did here. Any questions up to that point? Okay, so yeah, there's nothing wrong with using the inheritance as you have seen, except that it sits up the one inheritance opportunity that cargo hold has. So if another class might be more suitable than stack to serve as cargo hold superclass. So assuming maybe there is another, yes, the stack does what we need, adding and popping from the array. What about if I still want to use stack? What about if I want to use the stack class, but also with another probably class doing some better functionality and properties. In this case, cargo hold is restricted because it can't do multiple inheritance. Yeah. So that's now where now the modules will come in. So if another class must be more suitable than Stack to serve as cargo hold superclass, like okay, we have a storage space and airplane, then we might end up needing the flexibility we gain by turning at least one of the classes into a module. So being that, yes, cargo hold inherits from Stack, but we have another class that cargo holds need just because it has some good properties. So the only way a cargo hold can use it is as a module, such that cargo hold includes that module. Yeah. So the main question, Getty.
Can a module have an initialize method? Because we're not actually creating an instance for that. Anytime we're creating an instance, it refers to that method. So can a module have the initialize set getter?
Okay, we can always test that here. So let me say I have a module Getty. Oh, then I have initialize. Initialize, then maybe I'm setting name to be Getty and my method and my class. Okay, at this point, initialize is just like a normal method. But so in this case, if we had actually this is going to be interesting. If I have a class A, then I have an initialize method. Yeah, which also no. Oh, I was not to define it. Let me control D. Let me have another class B that include module. Oh, include Getty. So what happens when I create an instance of a class at this point? Yeah. So let's see. I'm creating a new. So what will really happen at this point? Any guesses, Getty?
I think it will read the initialize method from them. It has no reason to not. You?
Yeah, I think I'm expecting it to go to the module, which is because new will search for the initialize method. If it misses it here, yeah, it will check the module. So I'm expecting to get, yeah. So I think now from here you can see that why new. The other one we were dealing with a class. So I think this is a good example of now why new actually usually this is a good example of how new usually checks for the initialize method. You can see the method what the return value here or the object here, you can see it initialized the name. So this it searched for the new method inside the class B, missed it. So the next method look up for the neighbor next door is the module get. When it goes there, it finds the initialize method, then executes it. Yeah. So there is a difference between classes and modules. The main ones being that actually not at the main ones. I think these are the two differences between a class and a module. So on that module don't have instances, we can always try that out by calling getty.new. So this undefined new for module get, yeah, undefined for getting module. But new, we can't use new when we are creating a new module. This is like we are creating a new module. Okay, we are creating this one. We are creating, yeah, we are creating a module. Yeah. We are creating an instance of the class module. Yeah. Then this point, yeah, actually, this is like doing. Let me say, yeah, this is just the same as this. It's just like, but it's the difference being that the name of this is Getty. Then this one probably maybe you'll assign it. So this will work because we are creating from the module class. We can always ask module. Module, what's your class? Yes, Getty, you have something. We are back here. Oh, we were to guess. Will we go back to? I have to search for this. I have to search for this. This is in Medium. Now let's look at, these are actually some of the blogs. Yes, I think this blog should save the day. So this is actually, we are talking of what is really the class of Ruby basic object. Yeah, there was that explanation. There was a diagram, a good diagram here. Yes, this one here. So from here, you have asked for the class of module. And I said it's classes. Yeah, because an object it inherits from objects. So meaning if we do module.superclass, you're expecting objects. But so this is the superclass. But what's the, so in Ruby everything is an object and an object is a class. So why is the class of module a class?
It's a class because it's.
So actually, what happens is everything here actually is a class. String is a class, numeric is a class, module is a class, class is a class, fixed num is a class. We can, let me try to check numeric dot class. I'm expecting class. If you check for which one else, yeah, integer, float, integer dot class, we're expecting class. But if we check for its superclass, yeah. Oh, no. From the diagram, yeah, it's numeric. It should be numeric.
I have another question.
Yes, good.
Can a module inherit from a class?
So, the way we have this Getty class, or Getty module, I mean. So this module to inherit from a class. So it's like a module. So actually, in modules, you do what's called namespacing. Yeah, but okay, let me just try that out. So you are saying module get it to inherit from a class. Okay, we can always try out that. Let's say it's a class C. Let's just not define anything. Then you have a module getty inheriting from module. Yeah, module. Yeah. Oh, another. Let me just create another module inheriting from C. I'm expecting probably is it a mismatch or something? I'm expecting actually what are we expecting? Yeah. It's a syntax error unexpected. So in short, yeah, the execution was going fine. Then it's wondering what is this now we are giving it this time. But to use modules, you do namespacing, whereby if I have module D, no, this won't make sense. Because namespacing with this, I'm expecting that the getty module is inside the D module. So in short, you can't do inheritance in modules. Probably you do namespacing whereby you have a module that has some other modules inside it. Yeah. Okay, so so it's useful to keep a couple of considerations in mind. So when you're making a class versus module decisions, you should note that two of these things. So modules don't have instances. Like we have just seen the new calling new method on our module that we created. So it follows that entities or things are generally best modeled in a class. And characteristics or properties of the entities or things are encapsulated in the module. Yeah, so for the classes, we have the entities or the things. Then for modules, most we have the behaviors, yeah, the characteristics or properties of these entities. We put them in the module. Yeah, then a class can only have one superclass, but it can mix in many modules at once. Probably if you will check in our previous videos whereby we mix in a class mixing in more than one module, you'll see this bit here. We did some a lot of examples actually. You can look in at that. So yeah, a class can only have one superclass, but a class can mix in many modules. So yeah, if you're using inheritance, give priority to creating a sensible superclass or a subclass relationship. So, for example, you can look here. We have a module vehicle. Then you have a class self-propelling. Then we have a class truck that inherits from self-propelling. So I think from this point, self-propelling is like a behavior, yeah? So how can a truck that has self-propelling inherit from self-propelling? Then the truck includes a vehicle. Yeah, you can see some. I think, yeah, from this point actually is where, because your inheritance should be, the relationship should be, let me say, sensible enough. So probably here, what we could have done is have a module self-propelling, which is self-propelling now is like the behavior. Yeah, so a vehicle, then you have a class vehicle. A vehicle has self-propelling, yeah? Any vehicle has this self-propelling. Then a truck, of course, a truck is a vehicle. So you can see this using modules and inheritance here. This makes more sense than this. Yeah, so yeah. So nesting modules and classes. So okay, let me just see the second version of modules of the second version, which is this models, the entities and properties much more neatly. Track the sensor when you down that. So nesting modules and classes. Okay, let's just have an intro of this. So assuming, Get was just asking, this is an example you could see we have a class inside a module. Because initially said that a module can encapsulate behaviors and properties, even objects, which is now the classes. Because in a class, actually, you can have many modules. Yeah, so for example, in this case, I have a module tools, then I have a class hammer. If I want now to create the hammer, actually, let me just do this. So assuming I have that module. So if I want to create a hammer class, I will go like the method lookup first. First, the hammer class is inside the tool. So tools. Then now you use, this is now the so-called constant lookup notation. So use this just to tell it, this is like a roadmap or what interlinks. For you to reach the hammer class, you have to pass through the tools. Yeah. Then you have your hammer. Then now you can create an instance of the hammer class. Yeah, so this here we have just done nesting. Oh, where am I? We have just nested a class inside a module. Let's get it. So if we did the hammer.new, so the way, okay, let me interpret this. So what will happen here? It is expecting that I have a hammer class defined. So if I do this, this means it's probably expecting something like this hammer, because if I do this, I'm expecting is it an undefined method new for because yeah, so probably it's undefined method new. Is it for nail class? Oh, actually, yeah. An initialized constant ham, actually, yeah, I think. Because actually the execution will start from here, then it will, if starting from H, it will find this is not defined anywhere. Yeah, so it's an initialized constant, yeah, hammer. But because this is expecting something like, if we have this, now this time, then we call hammer dot new. This will work because we have a hammer class. So this is like, if we do this, is like the first thing it will check is the hammer. But this will work because now we have a hammer class. But in this case, what we are trying, method lookup, goes like stepwise. So with this, we mean that we want to first see if this hammer class exists, but then it finds it doesn't. Yeah. But here, the hammer class is inside the tools. So method lookup cannot jump to the hammer class. It will first pass through the tools. Then in the tools, now you can access the hammer. Yeah, okay, guys. Yeah, I think next meetup, I think we'll continue with the nesting modules. Oh, we are almost clearing the chapter. So next up, we'll continue with the nesting modules and classes. Yeah, and I'm seeing almost ending actually. Yeah, it's like we'll end the chapter and probably begin chapter 5 in the next meetup. So thank you guys. It's been awesome. Till next time.
Bye.
Bye bye.